All right. Good morning or good afternoon, depending where you are in the country today. Thanks so much for jumping in. We have today our phase 3 modern data center presentation, which is the enhanced agility across the modern data center. So, with myself and Nutanix from coming in, we're going to do a quick presentation. A couple quick things to note just today. If there's any questions, please do feel free to put them into the chat as we go through. I'll be covering some topics at a pretty fast pace, high level. Most of them will probably be conversations that would be an hour in and of themselves. So as we go through, if there's something that really hits in there, make sure to reach out. Any of us on the chat will send you some contact information and would love to have a conversation afterwards. So a little bit about myself for everyone that's joined today. So my name is Ryan Beauchamp. I'm a principal solution architect based out of Vancouver, BC. I cover nationally for a couple different products and technologies within CDW. That includes data center, hybrid cloud, backup, DR. From the HCI, I'm one of our practice leads for multiple different technologies. Same with our virtualized desktop infrastructure. And I work as a technical account manager for some of our largest companies that CDW supports as a single kind of point of contact for everything and anything. I've been in IT 20 years, so I've probably seen it all, done it all, worn the hat. So I look forward to chatting with everyone today. And with that, I'll probably kick right into the conversation. So a little bit about CDW. Really, we're here to enhance your data center technology. This really is redefining what it means to do on-premise as well as cloud. We want to take a look at what business approaches you're doing today and where we can enhance and increase velocity for your business to achieve those most complex problems that are out there. We want to look at different upgrading specific components, how you roll out from a small deployment all the way up to large deployments across multiple continents or multiple sites if you're distributed all across Canada, which can be a challenge in our very vast nation that we have coast to coast. So a couple of things that we can help you with to really kind of achieve that digital velocity, like I was talking about, is anything in the infrastructure services, whether that be HCI, that's storage, compute, or just infrastructure as a service, platform as a service. We're really here to help and expand what you can do and be that kind of guide for you in this space. For workspace services, we have a full collaboration suite, a bunch of technology solution architects that across the country. In all of these areas, CDW has 300 plus architects that are here to really help you, whether it's in your networking, data center, cloud, support services, all the way into AI, ML, and automation, which we'll talk about a little bit later today. So enough of the marketing slides. Really kind of jump right into what we're really kind of focusing on here today. And that's the CW's modern data center journey. So we're already in phase 3. So I'm going to touch upon a little bit where we talked about with phase 1 as well as phase 2. So with phase 1, we really talked about data center being the bedrock of innovation. It's where most organizations still host most of their critical data. We talked about enhancements in power, cooling, what data management opportunities that are there to restructure and optimize. And then also how companies are collapsing their infrastructure to optimize, to really get that cost and performance out of what they have today or reimagine it in a different way. And one of those products is HCI. Nutanix will talk a little bit later today when they get in here. One of the phase 2 was one that I had a lot of topics and a big conversation with last time. If you caught my presentation, feel free to look us up on YouTube. We're back there. You can rewatch any of our phase 1, phase 2, or go visit our modern data center topics. There's a bunch of blog posts that we've written and put in front of you. So the phase 2 was really enabling that hybrid data center and extending out from the private data center to the public cloud or private clouds, depending where you wanted to go. We wanted to talk about the workload placement, some topics around data gravity. Also look at the data footprint in your environment. Let's look at leveraging tiering for cold data, assessing what your current disaster recovery options and what enhancements or options could be available in a new hybrid environment. Maybe instead of a disaster recovery data center as a second site, let's look at an active data center in the public cloud with the ability to have a burst all of your resources into the public cloud in an on-prem disaster, or vice versa, depending on how we wanted to architect it. We also looked at building new applications in like more of a cloud native, cost-effective solution, maybe repatriating them from that initial development and ideation in the cloud to on-prem and what that looks like. So it really has that full portability in there. Today on the phase 3, we're really going to talk about enhancing that data center. So we talked about the data center, we've talked about expanding out into the hybrid. Now, how do we wrap all of that together in a more agile, software-defined data center for you? So a couple of topics I want to look at here is really it's about simplifying, reducing some of those dependencies that we're talking about. So as we transition to more modern data centers, we start to look at some of the hardware a bit differently while abstracting those resources for the hardware and caring more about the data and the applications themselves. Looking at what we're talking like, we've all talked about virtualization for years. And so we already have a fairly good understanding of what abstracting that hardware really means. In AWS and Azure, for example, in the public cloud, we don't need to really care what that hardware is underneath. And really that's kind of increased that perception in the on-premise data center and gives us a chance to rethink what that infrastructure is doing for us. So today there's more API controls to abstract the compute, the memory, GPUs, move to that software-defined networking, centralizing some of that management. We'll talk about that. And really it's focusing on what is important to you, as well as managing your data center with far fewer clicks, fewer IT staff, or refocusing some of your IT staff for what is more important to you. Now on the screen, you'll notice there's an Apple logo. This is not by chance. I actually chose it because honestly, I think iPhone was probably one of the best things that happened for IT, not really just for phones. It really showed that that platform can offer something that's easy to use, simple, and everything you can have at a one glance. You can add new applications with a few clicks, and everything gets installed in the back end and configured. Much of this is the same in IT when we really look at where we're going. A cloud software-defined data center really enables proprietary hardware dependency from your system. So that software-defined data center is going to be independent of the command line interface, offers simple API hooks into the underlying infrastructure that we can control and program, eliminates that need for extensive training with highly specialized individual vendor software and hardware, and frees up your IT staff to focus on the business challenges that are really there for you today. So let's take a look at what that really means when we talk about the software-defined data center. None of this is really new. We've all probably seen this for around 10 years. What's new is really the fact that we're getting more of those APIs are prevalent in the underlying hardware that then the software stack layers on top, so we can start leveraging those innovations and ease of use. So taking the hardware, abstracting each layer, gives us that full control, put in resource pools to add in those new workloads in maybe a more optimized fashion. That test dev environment does not need the same amount of resource priority that your mission critical workloads really do need. So this gives you that opportunity to start pooling things together, grouping them in logical orders for your tier 0, tier 1, tier 2 applications within your data center. And looking at the different vendors that are out there, there's a bunch that have this. Nutanix is a great one that's coming up that Dal will be able to talk about down the line. Or any of the products, whether it's AWS, VMware, Azure, we can talk about those at length on how to optimize your environment going forward. So the compute virtualization, really, we've all done this. It's since like 2003. The big one here is network virtualization, that software-defined networking. It lets the administrators and the cloud networking engineers have a centralized control console. And this console allows them to really respond to changing business requirements, helps them manage and provision those networks independently of any of that underlying hardware. So that virtualized network has multiple different types of technology. We try to standardize on one so that we're working with the same APIs. We're not having different things, but it then allows you to extend out from one single point of click to everywhere in your environment. Storage virtualization, that's your Nutanix, AOS, it's your vSANs, any of those that we really want to take a look at. Really taking that software-defined storage allows you to add any of those SSDs, hard drives, or even memory storage into the environment to enhance those applications and give them the proper performance. And then underneath, let's hot add as many software-defined or storage disks that we want to give you that availability. Maybe you want to tier it into the cloud. All of that can be done through a simple console when we get into that software-defined data center slide. So none of this really happens without the process of automation. Like the last piece there was management and automation that I skipped over a little bit because really I want to talk about this on this slide with the removal of that manual complex IT services. It will help you increase that business workflow. So using the software-defined data center automation tools and those management solutions, we can ensure that those business critical functions are working around the clock, not just in the 8 to 5 when your IT staff are looking at it. So this also ensures your IT staff can focus on other more pressing business challenges or those projects that we really need to complete. I know there's a lot of projects right now that customers are talking to me about what can we complete before the end of the year with budgeting. If that's not the case, I would be surprised. Also, we want to remove those manual complex services that you're doing. So let's take those repeatable actions and script them. Let's put in an automated response so that if something breaks, it automatically takes a look at what it is and follows a workflow and process that you're going to have it fix without any IT oversight. We can even go in as far as having that automation workflow open up your tickets with your OEMs to create a hardware service ticket so that if hard drive fails, it's already ordered and it's on its way before IT even has a look at. We might see the alert, but the automation process on the back end has taken care of everything that we want it to do so far. And then we just need to show up at the data center and pop out the drive, put a new one in, and those resolutions are completely actioned without any IT involvement aside from acknowledging that, yes, this has happened and doing the manual process that we can't quite get away with in the private data center of physically putting in a hard disk or a memory DIMM or power supply. So what does it mean when we talk about the automation here? So some of the base layer is that's your private public cloud, whether that's going to be on Azure, it's VMware, AWS, or Nutanix. Then we move up the stack to that automation engine. This is your Ansibles, your Terraforms, Chef's, Puppet, and that's really where we start to automate those workflows, create and add those into those self-service portals so that your teams are having repeatable actions. We're having predefined deployments. So there's no more, oops, I forgot to click this. It's very scripted. We can deploy this once, or we could deploy this 1,000 times, and that initial configuration is not going to change. And then at the very top here, like we're dealing with platforms now that not only are Windows and Linux, but are very quickly becoming Docker containers, Red Hat OpenShift, Kubernetes workloads, and all of these need to work together in a single platform that is either on-prem or in the cloud, or needs to be able to deploy to both. So utilizing some of these new tools really saves you some time because you can abstract what those resources are, deploy them wherever you need, and very quickly and repeatedly. So what does that workflow look like, and what's some of the benefits of applications and the uses of infrastructure of code? So really it's to it includes your visibility so that we as IT administrators, we know exactly what we're deploying all the time because we have it written down and it's repeatable. It's stable, so we have version control. So we write what our infrastructure as code is, whether that's an Ansible or Terraform. If we make any changes, that goes into our version controls to make sure that we're up to date. If there is a break that happens, we can quickly roll back to the last stable version that was in there, and then go back to the testing version. And it also allows us to scale. So really the most important pieces are reliability and scalability. So with that repeatability, we have security in mind. There's never a time that I don't do something with security. And really we achieve this because the same settings are utilized for each and every instance of that template. That verification that we have is provisioning a stable ready to run, and it ensures that if there is a failure, like I said, we can just do a quick rollback. And then operations can continue, or that we can just temporarily suspend what we were doing during that project, and then work on that prescribed workflow. Scalability is equally important, like I was saying. Building that library around reusable codes set really allows us to take that template model and deploy it where we need to. Let's say a particular region, we've all run into Azure going down. This is where that software-defined data center comes in. We're in both data centers. We have controls in both. It extends to, so let's quickly redeploy to that on-prem. And we have this infrastructure as code to instantly port that over. And that automation server knows what resources are available to it in the on-prem or in the cloud resources. So something that we've really kind of talked about, and where do we really want to go from the infrastructure as code in that modern data center, is the term platform engineering, and how that directly integrates into IT operations, and also enhances our IT agility. As it currently stands, IT operations is generally the people that own the platform, and really they need to understand what their users and groups are doing so that we can prioritize what we're doing, and then build out a platform that is usable to that target audience. So using the building blocks that we have just talked about from the software-defined data center and infrastructure as code, with tools that platform engineering takes the traditional IT operations mindset and then really improves it. It takes that developer experience and productivity of providing that self-service capabilities, automating that infrastructure operations, and then it allows us to accelerate product teams and delivering to organizations. So the goal here is really that frictionless self-service developer or business unit experience, offering the right capabilities in the right place, whether it's on-prem or in the cloud, with as little overhead as possible. So the platform should really increase that, reduce that cognitive load on IT staff, and allow you to give the developers or the business units whatever they need in the best fit. So this is really going to develop a new generation of tools, and making platform engineering one of the hottest topics that we're really kind of talking about within that DevOps side of the community, because it's becoming more prevalent in the IT operations that I'm dealing with on a day-to-day basis. So really, in short, like we're looking at improving the developer experience. We're enhancing those self-service capabilities. We're standardizing the tools and processes, which is what really streamlines. The less unicorn environments that we have that are out there that you have to manage, the quicker we can take those on-premise and cloud workloads and move them where we need to because we're using a standardized set of tools and API hooks for them. So that's really kind of what I wanted to talk about here in the phase 3. There's a whole website that we have, so please do go check it out. You'll see a link probably later on. Phase 4 is coming up in December. We're going to really talk about modern workloads in the data center. So where the organizations are committing to containers. What does that mean for you? It's become not a topic about, hey, are you using them? It's how are you using them now? We're going to look at how to manage that container workloads in traditional workloads in that same platform. What are those requirements? What's the tools that are needed to simplify some of the new asks that IT operations is really getting on a daily basis? So take a look at that one. Now, I know I've spoken a little bit about the platform in the past couple of minutes. And next one, I'm going to introduce Dow, who's a senior systems engineer from Nutanix, who's going to take over and expand on what Nutanix is doing in their Nutanix platform and enhancing the agility through their hybrid solutions and automations. Dow, I'll let you take over from here.
Awesome. Thank you, Ryan. Good afternoon, good morning, some folks, I guess, out west. I am one of the senior systems engineers here in Toronto, Canadian as well. Thanks CDW team for having me on. Just to confirm you guys are okay to see my screen?
You're good to go.
Okay. So great sort of tie into what Ryan and the CDW team has been communicating so far. How you guys modernizing data centers, what are those core components that you need? Lots of different options out there for you guys. By all means, there's a lot of different tools that can get the job done, but how can we get the job done to a point where it gives back more time to your developers, to your IT users, to your engineers, to your overall teams, right? You guys want to focus on the actual application. Sort of going with the analogy of the iPhone, right? Everyone doesn't care about their phone anymore. They just care about the apps. If I can tweet and I can go in my LinkedIn and I can do all my sort of things, that's really what I care about. The mantra, the idea of that is really what has been in Nutanix's blood since the beginning, right? But we always go back to, what is the problem that Nutanix solves, right? So if you've heard of us in the past, or if you haven't, we've been around the industry for about 12 years or so now. We're based out of San Jose, a global company as well. I have about 50-ish folks in the Canadian region, and sort of just helping a lot of our customers. We always want to talk to our customers to understand, what are the problems they're trying to solve? What are their overall challenges? What are their needs? What are their strategies and futures? And really see if we can help align what we see in the industry to what their overall build. So the question we always start off with is, what is your digital transformation strategy? What are you doing to keep the company as agile, as modern, to be able to keep up, right, with the business demands, etc. Because there's a ton of technical challenges that most folks don't really want to work on. They just want to get to the application. They want to be able to deliver the business requirement without having to worry about a hard drive or a disk or does my environment rebuild. I need to make sure that works. It needs to work well, and that's all I really care about. So when we get into that level of conversation and we talk to our customer bases, we sort of always ask, who are the personas, right, that use your technology today? What are their requirements? Are they developers that have to consume everything through API? Are they operators that have to come in and make daily changes in the environment that consumes up most of their times? Are they engineers that need to develop additional applications and build on a platform that's agile enough to meet their overall requirements? Everyone comes in and says, I want to have something that's very agile. I don't need to worry about my data center. I want to be able to just get things to work. So everyone tries to build their private cloud. You guys have heard of OpenStack in the past, seen all those different solutions. Those ideas is what really spawned the public cloud, where folks weren't able to really do these things on-prem, right? I have challenges of complexity, multiple vendors, storage, networking, the list goes on and on. So when an application developer comes through and says, I need these application components and requirements, the challenges they run into really just makes them say, okay, let's put that aside. I can only solve this if I have something that's very simple to use, simple to consume. So hence they go to something that's easy to use, which is, these days public cloud. Great solution idea. A lot of startups doing all that overall. Lots of benefits. Instant scale. Public cloud has really redefined what it is to sort of consume simple IT, which is great. A lot of companies will go that way and stay that way overall. The Canadian marketplace, I'd say we're still making that path over towards there, but there are a lot of requirements to keep control over my data, have things on-prem, know exactly who's accessing my data. I can start looking at public cloud, but are my applications primed for that? Does it work well in cloud? Is it supposed to be something that I run and I want to rent all the time? Or are my applications themselves very static, that my workloads don't really burst? Do I have to take care of all those advantages? So when we talk to CIOs and CTOs to see really what they're overall doing, challenges or questions we ask is, why are you going to cloud? What is it that you're looking to consume and do there in the cloud? A lot of folks will say that's my cloud first strategy, but can't really give us a reason as to why. And primarily, when you dig that back down to the core, it's I need to modernize my infrastructure. I need to transform my digital environment, but I need to do it that matches my overall requirements. What Nutanix has really built is really a method for you to do both, right? I can consume something in simplistic manners. I can choose where I want to consume that, and I don't have to really get tied in to a hardware vendor or a specific bespoke type of hardware or a SAN, or really have a full-on IT team that can be bogged down and be put into silos. We want to make that simplicity consumable, very easy to use, very easy to scale, while still maintaining performance and resiliency is key, right? So the product that we've come out to the marketplace is really what's called Nutanix operating system. Let me sort of back this up a little bit. There you go. Software, right? As Ryan's been mentioning, software-defined data center is really the data center of the future. How are you adopting that today? What enables you to provide that to your personas, your end users, your application developers, your engineers? What are their requirements? Are they going to cloud? Do you have full visibility into that? What are those overall challenges that's preventing you from becoming that top tier provider of the space that your company is in? And that's really the challenge that we look into the marketplace and say, what can Nutanix bring to the marketplace that makes that job, that task, as simple as it is as the iPhone was, right? So the first thing you always start off with is, my infrastructure. I want to be able to manage everything as simple as possible. I don't need to worry about those dials and knobs. I want to make sure things work. When I go to public cloud, a lot of folks will say a lot of service delivery is guaranteed there because of just the amount of folks that use it, but they don't really worry about those individual knobs per se. They want to care about what can I actually deliver. So when we look at most basic virtualization workload like infrastructure services, virtualization, that's the board, as you guys know. Do I need to tie that into a specific type of hardware, a certain vendor, for instance, certain hypervisor? I should have the ability to have that flexibility to choose what I need that matches my requirements. If I need to have solutions that tie into vSphere or VMware, because it's part of my automation stack, it's part of my disaster recovery stack, I need to be able to use that while still maintaining the ability to modernize that data center. What if I don't care about my hypervisor? What if it's just I need to have vMotion capabilities? I need to have the ability to have my environment stay up and running regardless of what happens. Do I care about the specifics in my hypervisor? Most folks who go to cloud don't really care, right? The hypervisor in the cloud is not a conversation point because it's the feature delivery that matters there. So having the flexibility of choosing my hypervisor should be an option there that just doesn't become a roadblock as to what you're designing and building. It's always based on the application, as I mentioned, the workload itself. So when we look at things like virtualized infrastructure that runs your typical on-prem, that's very standard. What am I doing for my core of my business itself, my data? How do I manage that today? How do I flexible, scalable to what I needed to grow? Does it need to be run in cloud? Does it need to be run on-prem? How am I protecting this? How am I giving additional copies to my developers to use and maintain to keep agility going? How do I define additional workloads to do things like provide just your simplistic block and storage for my applications? Do my Citrix users need Citrix profiles? Do my users need SMB shares, for instance? Do I have to talk to NetApp or EMC for a large SAN in this environment? Can it scale? Is it cloud ready, for instance? All those sort of solutions are months and months of work to really just build that upon there, right? We sort of move on to things that, as Ryan mentioned, is cloud native. Do I want to build this in something that's built into a cloud solution? Kubernetes itself is portable as is, but As we know, the environment is still maturing, especially in places of replication protection, spanning across environments. The application requirements typically require the design to take care of replication and resiliency versus infrastructure. But how do you do that from a standpoint of modernizing your current apps into that environment? There's always big challenges there. It's a very complex environment that our friends from CDW can help you guys with. But again, what are the options and flexibility options that I have? And then we sort of move on to things like AI/ML. If you're doing research, if I need to have physical hardware that can help me with that processing power, do I need physical GPUs? What software vendors do I tie into? Again, lots of different components to just give your developers and engineers the edge that they need, but gives you that flexibility as to where I want to put that. And then end user computing, probably the heart of Nutanix when we came to the marketplace is how do I take a very sort of tough solution with 3-tier? When I say 3-tier, that means compute, storage, and networking tie in together. The VDI always was one of those challenges where typical storage area networks weren't able to handle things like burst workloads, weren't able to scale as well as the requirements are. So we took that workload, sort of grabbed them by the horn, resolve that in the marketplace, built a scale-out architecture that linearly scales with performance and requirements, and really put our place in the market, starting with VDI. When we solved that performance issue, being able to solve additional tier 1 application requirements just came with the maturity of the product. And today we pretty much can handle 95%, I would say, of most of the workload requirements that are out there. You definitely will have environments that are bespoke and can do things a lot more efficiently. But do you want to take on the overhead of managing those individually with a team dedicated towards that? Can I bucket my environments into a solution that's very agile, gives me most of what I need, and as Ryan mentioned, I don't have to have a dedicated team to manage that. I can have them focus more on the actual deliveries that make sense to the business. Tie all those workloads together, disassociate yourself from the hardware, give yourself that flexibility. Then you can say, okay, now I need to manage this entire thing. If you talk to some folks who have used Nutanix, I know we have some customers on the call here today that are using Nutanix. Ask them about their experience for management, right? This goes back to the UI, the interface, that beautiful sort of Apple environment. How well does this make it so that my engineers can come in and develop the workloads? Can my operation teams come in and not worry about hardware, performance issues, or have any challenges with hardware updates, all those sort of things? Those should be simple clicks and taken care of, like your updates on your phone. Being able to do something like that just means that I don't have to worry about the hardware. I can look at lifecycle management as just a thing in the past. And regardless of the hardware vendor that you choose, Nutanix takes care of all the hardware lifecycle from that standpoint while maintaining uptime for all the overall workloads. So again, it's click a button, update the software, all prerequisites, all components, etc., get taken care of, regardless of the vendor that you guys choose there. Make it so that your users can now come in and consume this technology as simple as they can. So whether it's using a physical graphical interface, whether it's going in through APIs to consume, whether you're putting Nutanix behind an automation system like Terraform and Ansible, ServiceNow, having your own change management tracking database, that's all flexibility based on how it works with your own design. And at the end of the day, it's just to make things simple for you to consume, right? That's the overall message that we've brought in here. And then being able to really, sorry, it looked a little funny there. Sorry, my presentation's a little funny there. Okay. When we look at enhancing this overall environment, whether I want to tie this into analytical services that are software SaaS services in cloud, things like being able to see my security compliance, being able to see my cost governance of my environment, being able to analyze things like my file servers to understand what data is hot, cold. I want to tier my two-month-old cold data, for instance, to S3 storage. I want to have full auditing capabilities for file servers that I'm running on-prem. All of those sort of things you can enhance with your environments with some of our SaaS services. But overall, because we're software defined, that core software technology really is portable overall. So if I have a solution design on-prem where I've built an infrastructure design code with all my automation in front of it to provision those workloads, consume this as code, how can I take the same thing and put it into a public cloud while still consuming my same provisioning and automation workflows? Again, because we're software in this case, we can consume bare metal services in public cloud and become just another computing target for that overall workload. So we have customers today that build that automation system on-prem. They look at modernizing on public cloud, but aren't really ready there yet to do a full cloud-native modernization. Lifting and shifting makes sense for some applications, but how can I make it simple so that I can do this for not only just one cloud, but for multiple clouds? Like if you have that requirement, you want to be able to take advantage of that flexibility. There are tools that are out there, but not many that can simplify and unify that entire API. So that's really the key message. And as I mentioned, in terms of governance of those different environments, being able to have a single view for this entire component, again, simplifies the life of the administrator, the IT team, the CIO, the CTO, to see what am I using, what's it costing, what's my performance characteristics. Is it bursty? Is it static? Bursty workloads, perfect for cloud. Static workloads, how can I easily move them on-prem? Because the platform, our AOS platform itself, stands for Acropolis Operating System, is software defined. Again, we enable that transparency across different compute environments to allow you to consume the services that you need, build them as you need to, make sure you can manage them all in a simplistic manner, and then keep your automation all in tune regardless of where I run the environment. I will pause there. There's a lot of information I shared. What you're really seeing is really the amalgamation of 10 plus years of technology maturity of our overall platform, growing into different companies across across the globe. So I usually open it up for questions right now, but I'll make sure I'll cover some additional use cases and customer stories that I've dealt with personally over the past couple years. Share those with you guys so you guys can sort of hear how our customers are consuming, and then we can always open up for questions after the fact. But this is a good sort of overview as to what we do today. Okay, so when you get into things like OpenShift, let's say you have an environment that you're building to make cloud native, you typically have to choose that platform. Are you doing this in a specific cloud? Does that cloud provide me with the flexibility and the cloud consumption credits that I need to use? Do I put this into Amazon? Do I put this into Azure? What if I need to move things around? So if you look at sort of on-prem based Kubernetes solutions that adhere to security requirements, there's a lot of different solutions out there. We've partnered with OpenShift in the past 4 to 5 months or so. That's been a brand new partnership and lots of traction growing with this. Being able to automate OpenShift deployments on my current on-prem environment, building an environment that my developers can use to do cloud native developer workloads and jobs, and be able to make that portable for dev test in cloud or run production on-prem. So there's a lot of good work happening in here. OpenShift itself will have to have solutions that provided things with block storage, with file storage, with object storage, for instance, with database services. That in itself as a solution design typically takes a lot of work to make sure that overall works. So you want to have some type of playbook as to how I want to build and run this. Again, that goes back towards how simple is my infrastructure to consume to provide for the application workload. So OpenShift is a perfect example where they can use our hypervisor itself to have no additional cost for, let's say, a VMware environment, being able to consume Nutanix storage services for things like object, block, all Kubernetes storage native protocols, everything all supported, for instance. And when you move further up that stack, when my applications need to develop, what type of database do they consume? That's always a big core component. If I can't secure my data and protect it, I'm always going to have troubles, even no matter how agile my environment runs. So OpenShift is able to consume databases from our platform as well. And that gets really into what we call database as a service or Nutanix databases. Now we get into a specific workload that says if I have components to where I need to provision multiple applications for my end users, they always require a database, but they need to have that provisioned relatively fast. I want to be able to provision multi-instance Postgres or MongoDB replica sets or Microsoft SQL, Oracle, for instance. I need to be able to protect that with different SLAs. I need to be able to do redo log catch-ups on my environment. What are my solutions that allows me to do that today? A lot of customers will have dedicated environments, an Oracle Exadata, for instance, or dedicated SQL environments just for those application workloads. And that itself takes a whole team to manage. When you look at provisioning those workloads itself, how to protect them, again, very challenging. one of the largest financial institutions here in Toronto. I've been working with for the past 18 months or so. Their challenge coming to us was they have bespoke environments, performance is good, everything works well, but when I need to actually restore something, it took them 3 to 4 to 5 days to recover a 3 terabyte SQL database. That itself just wasn't acceptable to the business owners. So they came to us with a challenge and said, what can your platform do for my environment if I want to be able to provision databases on top of what you can run, but be able to automate this all behind my own backend portal? So we took on the challenge, did proof of concepts with our overall solutions. NDB, Nutanix database as a platform, is built on top of AOS. So whether you're running this on AHV or ESX, the platform itself, we've taken care of that component. They were able to provision, started off with Postgres and MongoDB workloads to say, I want to be able to do single instance, multi-instance, all through API, provision that workload, populate it with a 2-3 terabyte workload, fail it, and then do a point-in-time recovery to 10 minutes ago. That typical job, as I mentioned, took about 3 to 4 to 5 days to recover in their existing environment. Because of our storage snapshots, how well it works, we did a POC multiple times and proved that the recovery time was about 15 minutes. So that wowed them. They were on board right away. When they tested, made sure everything worked, they were very happy. So SQL was the first workload we tested. Now we have an on-prem environment consisting of about 30 physical servers, just as a lab environment so far, to test Postgres, to test Mongo, and MS SQL as well, and potentially in the future, MariaDB. But the idea was they provided database as a service overall to be able to create that. So I see some questions coming through. Let me pop that so I just make sure I don't miss those.
It was a question of what database server was that example that you were just talking about. There down.
That 3 terabyte database server was a Microsoft SQL always-on availability group. So 3 instances across one cluster, and to do a point-in-time recovery, and then have that sync across the additional copies. That was from Leonard, it looks like.
Yep, and while you answered it, you got the second question as he typed it at the same time.
So so the same thing. If you're doing this test for single instance or multi-instance, for instance, the way Nutanix does storage thin snapshots, how we do block-based mapping, makes it so that you can actually mount and remount our object storage, our block storage, file storage to the virtual machines pretty simply. The time it took to actually run the operation was actually doing redo log catch-ups to expose that to the system, all the automation systems in the back end to authenticate that server to provide that volume group and to make that work, and then provide it back to the end users to say this is done. But because we put this in front of a self-service window, users can consume this on their own, right? The beauty of that was this customer that I'm talking about, everything that they run doesn't run on a GUI, right? We have this full GUI that they can use. They actually did everything behind their interfaces. So they built their own automation systems that takes care of network control, that takes care of user access, chargeback, cost centers, etc. And then used us as just a consumable API. So if we go back to those personas, that was the developers and engineers working together on this to go through. So that's still ongoing. They're testing out more and more. They're asking for more and more features. Recent tests we're doing now is things like tying in DB patching with OS patching. So we do everything at the same time. Huge uptake there because that can save their IT teams multiple hours per month just from doing security patches on their environment. So that's a great component. And then when they need to provide developer copies of additional databases, regardless of the size it takes, even if it's a 10 terabyte database, we can create clones, provision databases that match the existing ones within an hour for that overall workload, which completely threw them off. I had no idea how fast that overall was. Again, back down to the core technology of how we made VDI very fast, thin provisioning, shadow cloning technologies that made gold images very fast performing across the environment, regardless of where you put your VMs. That technology is the same thing we use in the backend here, just with database smarts in front of it. So very unique solution that nobody in the marketplace can do today. Hence, there wasn't even an RFP for this. It was really just, do I want to build this myself? I have the engineering folks that can build this, but they don't have the smarts to build everything from the backend storage. So they looked at the solution product and said, okay, this is going to save us. This can be the core of my database services, and then off it goes. Yeah, sorry, Leonard. I think everyone's muted. I'm not sure if Kimberly, if you want to unmute Leonard, you can jump on for a conversation. That's okay. Go ahead, Leonard. Yeah, that's fine. Go ahead. So as Leonard's typing his question, hopefully this sort of showcases some things that NDB can do. The beauty is, as I do this with containerization, OpenShift has an operator that talks to NDB, right? So I can tell my developers who are using OpenShift to say, I need a database, make an NDB call, and then that actually just gets pre-built so they can get a single instance, a multi-instance Postgres database right from their start without having to actually touch a database instance or a team itself. And the beauty behind that really is to get that type of service today, I have to go into public cloud. Right? I need to be able to do this with either Amazon and use only their instances, or Azure and use only their instances. But I lose control of my security patches, of what my OS can see. This customer needed to have that level of control. Hence, this was a solution that made sense for them. Let's see, regarding the example before. The always on availability instances were residing on one Nutanix cluster. We built second phase of our on-prem test bed where we actually have two physically separate Nutanix clusters at two separate sites, still managed by one NDB instance, right? NDB is really just the management plane. Where I run the database itself can be completely separate. Case in point, what we're doing now with that overall solution design is not only do I want to be able to control and provision this on-prem, if you recall, NC2, which is our Nutanix cloud clusters in public cloud, again, is just a Nutanix endpoint. So now we're testing out to be able to put a copy of Nutanix on a public cloud, point that to my NDB management plane, and now when I say provision a SQL always on group, I can have two local copies on my data centers. They can be in sync because I have low latency. I can have an async copy in public cloud, and that becomes a third copy, for instance, and I have full flexibility to manage that all within a single place, at the same time using my same APIs that I've used past 12 months to develop. So very strong story from there as well that takes advantage of our cloud clusters to make sure that you're, again, not reinventing the wheel, have the flexibility to do what you do today, but still make sure that my agility is still there, right? That's sort of an amalgamation of all of the automation they put into place while still using us as just that core platform. So hopefully that answers your question, Leonard. Correct, yeah. So the workflows themselves, we can always get into what that looks like. There's a lot of smarts underneath the covers that our team takes care of so that you don't have to build that into your engineering workflows, right? Because we understand our storage, we understand our tech, and we understand databases. So that helps the end user not have to worry about that. I have another customer that also adopted the same product, wanted to understand how it worked, and then took that idea and built their own automation behind it. So they're able to do provisioning job workloads. But when it came to things like copy data management, to understand thin provision snapshots, do this on-prem, do this in cloud, that's what they lacked, right? So this is an all-in-one solution that helps with not only provisioning workloads, but you have to think of day two. You have to think of resiliency and copy data management. And if I can recover that fast, if 6 hours is worth it to the business versus 6 days, that's a conversation we can always have. Okay. But again, goes towards what we've been adding on top of the platform. You may hear of, Nutanix as a hyperconverged player, AHV as a hypervisor to replace VMware. These are all core components that still just add up to what's the end story do you want to get to. If it's application development, we can help there. If it's database operational management and simplicity across multi-cloud for your database platform, great story we have there as well. But those are elevation points that we want to have with our customers to let them understand what this platform can overall do. And the POC was only about 2 months. Database itself is a complex solution to solve, but it's core to the business. So always have those conversations. How am I doing this with my current environments? What's my future modernization strategy? Can I do this in public cloud? Can I do this on-prem? And does it match my overall requirements as well as my RTOs for recovery times? So big portions over there, but I think that was a really good story that just showcases what the platform can do. And this is still ongoing from my end. That's I wanted to make sure you guys were aware of. Thanks, Leonard, for all the questions. Hopefully that's good. To keep the questions coming if you guys have anything else. And that's really about to time. We have about 10 minutes left. Wanted to put this out there in terms of what the current platform portfolio looks like. mainly because there's a lot of different ways you can consume our product and consume our ecosystem, really. So databases was just one portion of that. Whether you're doing this for just virtualization, role-based access control to build your own private cloud, I would say most of our customers consume us for VDI tier 1 databases. We've recently enhanced things like performance to get things like Meditech certifications, Cerner certifications for healthcare. A lot of folks will look at a platform that can, again, scale and build and not be a nightmare to manage. Hence, we've really made a difference in customers that overall have adopted different portions of our solution. But again, it's all based on what you guys are using to build, what the requirements are. So have the conversations with us, have the conversations with your CDW team. Happy to have further conversations for this. Again, Leonard, thanks for all the questions. But that's it from me. Ryan, I'll pass it back over to you. Still there, Ryan?
Yep, sorry, I am definitely still here. Dow, thank you very much for the presentation today. I think with everyone here, thank you very much for your time. If there's no other questions, I think we can probably wrap up here today. But we look forward to next month having the phase 4 rollout. So please do stay tuned. Make sure you hit the website for the Modern Data Center initiatives that we have. There's a lot of great content that's in there. And if there is anything else that you wanted to expand upon, I know I covered fairly large topics in a very short amount of time, which could probably be a longer conversation for any single one of those. Please do feel to reach out to any one of your CDW representatives, and they'd be more than happy to put you in touch with me, and we can have another longer conversation. So with that, Kimberly, feel free to end the session here, and we can kind of call it a day.
Great. Thanks, everybody.
Thank you, everyone.
Have a good week.
Thank you, you too.
Sorry, Stefan, was it a question? Oh, just a question. Okay. Okay, everyone, take care.
Yep. All right. Thank you, everyone.